Have you ever had a brilliant, deeply complex conversation with an AI, only for it to completely forget what you were talking about like 5 minutes later? It is incredibly frustrating, isn't it? Well, that exact problem is literally the greatest bottleneck in AI development right now. Okay, let's dive into this. Welcome to this explainer on agentic engineering, where we're going to break right through that bottleneck. Today is day 10, and our focus is entirely on memory systems. We are going to take the abstract idea of an AI's memory and break it down into the literal, actionable engineering components that make a true autonomous agent possible. So here is our roadmap for today. We'll start with a quick day 10 overview and then systematically unpack our 3 foundational learning modules: short-term memory, long-term memory, and vector memory. Finally, we'll bring all of that together for your culminating practical capstone project, the Personal Memory Agent. All right, Section 1, Day 10 Overview and the Learning Objectives. Mastering memory is the absolute fundamental building block of a true AI agent. Mastering this isn't just some extra feature or bell and whistle. It's actually what separates a simple script from a fully autonomous agent. Our learning objectives today cover 3 distinct puzzle pieces: short-term memory, long-term memory, and vector memory. As we decode each of these terms, really keep our final project in mind. Think about how you're going to combine these tools to build something totally new. Moving on to part 2, short-term memory, the immediate layer. Now, what's really interesting about this slide is how it frames the immediate, foundational layer of AI recall. Let's unpack this definition kind of slowly and deliberately. The source material defines short-term memory as the immediate, temporary recall utilized by an agent during its current operations. Notice the structural implications of those words, immediate and temporary. In agentic engineering, short-term memory is a strictly temporary holding zone, but make no mistake, it is an absolute engineering necessity. Think of it like a workbench. When an AI agent is working on a task right this very second, it needs a place to hold its tools, the prompt you just gave it, and the context of the immediate conversation. It's highly accessible, extremely fast, but inherently limited in size. The moment the task is totally finished, boom, the workbench gets wiped clean for the next job. Which brings us to part 3, long-term memory, persistent AI recall. This is where we evolve from immediate reactions to true, enduring persistence. Because, let's be honest, a workbench alone just isn't enough for true intelligence, right? We need enduring persistence. The definition here is the persistent, enduring storage allowing an agent to retain and access information across time. We are talking about the sheer, massive technical challenge of retaining data way beyond a single fleeting interaction. This isn't the workbench anymore, no. This is the infinite filing cabinet in the next room. It's what allows the agent to recall who you are, what your specific preferences are, and even the conclusions it reached, say, 3 weeks ago. Let's actually put these two head-to-head for a second, because really understanding the contrast between short-term and long-term memory is absolutely critical for any agentic engineer. Just look at the delicate balance required here. On one side, temporary architectures, that's your short-term memory, give you speed and immediate context. But without long-term storage, every single interaction with that agent is day 1. It is a perpetual blank slate. On the flip side, persistent architectures, your long-term memory, give you history, depth, and continuity. But if you try to cram an entire lifetime of long-term memories onto that immediate short-term workbench, the agent will completely freeze up. It would just be overwhelmed by data, entirely unable to process the immediate task because it's too busy sifting through irrelevant history. True agentic engineering completely changes an agent's capabilities by perfectly choreographing the dance between these two systems. It's basically the art of taking exactly what is needed from that persistent long-term storage and placing it gently onto the short-term workbench, right when the agent actually needs it. So how do we engineer this memory? How do we actually bridge these theoretical concepts of time and memory into a highly technical, functional reality that a machine can actually use? That leads us to part 4, Vector Memory Explained, the Technical Core. So the crucial point is how this advanced concept acts as our technical solution. Let's look closely at the precise definition here: the specific structural and spatial memory format engineered for advanced AI systems. You see, human beings remember through connections, but machines, they require vector embeddings. Vector memory basically translates human concepts into a structural, high-dimensional spatial map. Imagine taking every single piece of long-term data and mapping it out in a massive physical room. Concepts with semantic similarity are grouped closely together in space, while totally unrelated concepts are pushed far apart. This incredible spatial engineering is what allows an AI to instantly search millions of data points and grab the absolute perfect context for its short-term workbench.
And honestly, that synthesis gives us the foundation of agentic memory. We've brought all three core components together now. We have the immediate, fast context of short term, the infinite, enduring persistence of long term, and the highly engineered spatial search mechanism of vector memory linking them all together. By mastering these three pieces, you've got yourself a fully robust architecture.
Part 5, the Personal Memory Agent Project, the capstone reveal. And this brilliantly illustrates our practical application for today. Here it is, guys, the Personal Memory Agent. This is no longer just theory or a syllabus line item. This is a thrilling engineering challenge. You are going to take the abstract architecture we just discussed and build a bespoke, highly functioning agent that actually remembers. This right here is what brings the entire explainer together into one really exciting, actionable build. Let's connect the dots on exactly how you're going to execute this. Step 1. Implement short term. You'll code the immediate context window so your agent can hold a fluid, real-time conversation. Step 2. Build long term. You're going to set up the persistent backend storage, ensuring that the data survives long after that immediate session ends. And step 3. Utilize vectors. You will engineer the spatial formats so your agent can seamlessly retrieve relevant long-term data and inject it perfectly back into the short-term task. This is the direct culmination of all our theoretical concepts today. This is exactly why everything we just learned matters for your capstone. So as we wrap up, I want to leave you with one final provocative question. What will your personal memory agent remember? You have the blueprints now. You know exactly how to build the workbench. You know how to build the infinite filing cabinet. And you know how to map it all spatially with vectors. The theory is yours. Now it's time to code. Thanks so much for joining this explainer, and I seriously can't wait to see what you build.